Hello everyone. Today we're going to talk about logarithms and logarithmic functions. First, let's talk about what a logarithm is. So a logarithm is another way of writing an exponent. It's really the inverse of an exponent. So if you have some base to the power of x, that would be equal to y. You can rewrite this as log, and here's your base, it'll be this little bitty number here of y is equal to x. The important part about that is that takes your exponent and puts it on the ground like so. It makes it into just a regular number. That's fantastic. So that helps us out quite a bit. So another way to think about it is I have some number to the power of x, and that gives me an answer. All right? Sorry, I'm recording this at school. And so now I can think of that as a logarithm. We denote a logarithm with log. I do write that in cursive quite a bit just so it doesn't look like 10g. Okay, so log base b of a is equal to x. And that's how you say that. So notice that it tells you right here how to read it. So the way I would read this one is log base b of y is equal to x. So one of the phrases you'll hear a lot is a logarithm is an exponent, because it is. If you take a logarithm, it would equal x. That x was in the exponent. So what you can do is you can rewrite any logarithm as an exponent. So let's practice doing that here. So my base is now the tiny number. So it's log base 2 of 16 is equal to 4. So my base is 2. We are equal to the exponent. And my answer is 16. And 2 to the power of 4 is 16. You would read this, log base 4 of 1 is equal to 0. So just as I read, I said log base 4 because my base is 4. My exponent is out here. It's what it's equal to, so my exponent is 0. And the answer is 1. And 4 to the power of 0 is 1. Try these two on your own. All right, we have log base 12 of 12 is equal to 1. So the base is 12, the exponent is 1, and that's equal to 12. Log base 1/4 of 4 is equal to 1. The base is 1/4, the exponent is -1, and the answer is 4. And 1/4 to the power of -1 is 4. You can then go the other way as well. So I have some exponents here. I'm going to rewrite those as a logarithm. So I'm going to write this as log base 2. So 2 will be my small number. The answer is 25. And that is equal to, oh, that is not my base. Y'all, it is time to wake up. Y'all, my base is 5. Do you see this? This is my base. Okay, so log base 5 of 25 is equal to the exponent. The exponent is 2. Again, I want to write this as a log. So I have log, the base is 10. The answer is 0.1, and that is equal to the exponent, -1. Here we have log base 8 of 4 is equal to the exponent 2/3. Try this one by yourself. Excellent. So I have log base 6 of 1/216 is equal to -3. Ooh, ran out of space there. -3. That's a -3. I don't really know what that looks like, but it's supposed to be -3. So let's go with that. All right. Now, you can also enter these into your calculator. So if you put a logarithm in your calculator, let's clear out what's in here. We have the logarithm button is going to be, give me 1 second to find it. There it is, right here next to the number 7. Right here, you see the log. We do need, though, to be able to change the base. So, give me 1 second to find that button. Okay, so if you just press this log button that's next to 7, you'll notice that there's not a base on that. So let me show you how to put a base in there. So you're going to go to Math, and if you scroll down to option A, that gives you log base. And notice there's a little baby box so you can put your base in there. We're just going to put this one in. So log base 5 of 25. And then if you press enter, it'll show you the answer is 2. Okay? Now, you may be saying to yourself, why is there a button for a logarithm, but they did not give it a base? I'm so glad that you mentioned that. That would be because, and that's actually going to be on this page, it is referred to as the common logarithm. So when there's no base, the base is assumed to be 10. And that's why, and that's very, very common. So that's why you can have a base, like a logarithm written with no base. The base is assumed to be 10 if the base is not written, okay? And you can, in those cases, a lot of times you have to use technology to determine that value, if that is the case. So for instance, here, we're going to find the log of 8. So option A asks us to find the log of 8. The thing to remember is that that means, right? That means log base 10 of 8. And you can use your calculator to evaluate that. You will have to round. It asks us to round to 3 decimal places. So in your calculator, you would use the button that's next to the 7, so log, and then you would be log of 8, and it'll calculate that for you. They use 3 decimal places would be 0.903. Now they also ask us to find this little value, ln of 0.3. Let's talk about that. That's called the natural logarithm, ln, natural logarithm. That's when your base is e, okay? So if your base is e, and we talked about e last class, then we don't usually write log base e of x. We just don't write that. We write natural log of x. It happens so often, it's easier to give it its own notation. So let's not forget that the natural log of 0.3 means log base e of 0.3. Now there is a button for that as well because that is so incredibly common. So you'll see the natural log button, or ln. You'll see that button right here. Notice it's an L and an N, not IN, ln. And you can press that button. It's right next to the 4, okay? And we can find the natural log of 0.3, which is, and we're gonna round that to the 3rd decimal place. My 3rd decimal place is 3. After that is a 9, so I'll round up. And that would be rounded to negative 1.204, okay? Well, let's go back to this. Something else I wanted to go over with you. Let's go over the number 1. So if you have a log base of 1, so log base b of 1, if you're taking the log of anything to equal 1, it's 0, right? Because anything to the power of 0 is 1, right? And if you have log base b of b, okay, so your base is the same as your answer, then that log is equal to 1 because anything to the power of 1 is equal to itself, okay? Now let's evaluate some logarithms. When you're evaluating a logarithm, the best thing to do is to think about it as an exponent. So just think about it in its definition, okay? So what log base 4 of 64 is asking you to do is it's saying 4 to what power would equal 64? Well, you can just think about that. What power would take 4 and turn it into a 64? Well, that would be 3, right? So log base 4 of 64 is equal to 3. Now here, again, I'm just going to think about it like an exponent. So my base is 5. They're saying, what exponent can I give to a 5 to get 0.2? Now that may not be obvious right off the bat. You may have to think about what 0.2 is. So let's take a minute just to think about that. So 0.2 is actually 2 tenths, correct? And 2 over 10 simplified is 1/5. So what they're actually asking you is 5 to what power gives you 1/5? Well, that would have been the power of -1. Let's say I have the log base 1/5 of 125. So my base is 1/5. They're saying, what exponent could I give to that to get 125? Okay, well, first I need 5 in the numerator, right? So 1 over 5 to the power of -1 would be equal to 5, but that's not what I was looking for, right? I'm looking for 125. So I would have to take all of this to the power of 3, right? So that would actually be 1/5 to the power of -3, power to a power rule, would equal 125. So 1/5 to what power gives us 125? That power is -3. See if you can do the last one on your own. Yeah, so 36 to what power gives you the number 6, right? So what I need to do is take the square root of 36, right? Because the square root of 36 is equal to 6. But can I write a square root as a power? Absolutely. So it turns out that I can write 36 to the 1/2 power would be equal to 6. So my answer is 1/2. Okay, let's talk about inverse properties. So the logarithm does have inverse properties. It will inverse an exponent. So let's look at that. If I have log base b of b to the power of x is equal to x, b, and then I have log base b of x is equal to x. So let me kind of like play that out in an example, okay? So let's do example A first. So it says 10 to the power of log of 4. 10 to the power of log of 4. Now notice I'm using the common log here. So we did not write the base of that log in. You have to understand that that base is 10. Well, the rule here says, right, that if I have a big letter here and then my exponent has that same base as the actual base, then the whole thing is equal to the a value here. So the whole thing is equal to x. So in this case, my base is equal to the base of my logarithm. So this entire thing is equal to 4. Okay. And then here I have log base 5 of 25 to the power of x. So what I want to do is sort of rethink this, because 25 could be written as a 5. So I'm going to rethink this as log base 5 of 5 squared to the power of x, because 5 squared is 25. But we know that the power to a power rule says this is the same thing as log base 5 of 5 to the power of 2x. Now, we have an inverse property that says if I have log base b of b to the power of x, that whole thing is equal to x. Notice my base, once again, is the same as my base. Once again. Well, that happened here. My base is the same as my base. So this entire logarithm must be equal to 2x. Because of these inverse properties, we can use logarithms to find the inverse of a function. So I think I'm going to do that. I think I'm going to do that on the second video.